Okay, let's continue with our discussions about introduction of our subject, physics. And as a review, what is a physical quantity? Physical quantity, of course, is a quantity that can be measured and consists of numerical magnitude and a unit. And the physical quantity can be classified into two, um, namely the basic the basic quantities, physical quantity, and the derived physical quantity. And then there are lots of physical quantities, but only three. There are seven actually basic physical quantities, but only three commonly used kinematics. By the way, so let's have this picture. Okay, can you see the picture? So we have in here the area derived, and then length times width. That's the relation with base and derived quantities. And the unit, that's in m squared. And what's the special name? There's no special name, simply square meter. How about volume? So we have length times width times height, so that's m cubed. Then there's no special name. And density, that's mass over volume. And for the unit in kilogram per m cubed, the unit for volume. And for the speed, distance over time, that's meter per second. Acceleration, that is change in velocity, and velocity is meter per second. And then over second, so that's meter per seconds, or this is equal to meter per second squared. And for the force, we have this mass in kilogram times the acceleration meter per second squared, and we have the special name for this in Newton. The pressure, this is the force Newton over meter square. So this is equivalent to Pascal, special name. And in work is force Newton, then meter. The Newton meter is equal to joule, and power for work, the joule per unit second. So that's in watt. That's the special name for this physical quantity, or this unit, derived unit. Okay, let me erase this one. So the system of units, we have the SI system. So the SI system uses this three basic fundamental quantities. The MKS. This MKS stands for, and then K for kilogram for mass, and second for time. So that's the reason why MKS. And we also have CGS system. CGS system. Of course, I think you can follow now the CGS. CGS stands for centimeter. gram, gram for the mass, and S for time and second. So the reason why it is CGS. There are other units. Example, mm, the British or the US or English British system of units. For mass, they use slug for mass, then feet for length, and second for time. So that these are the units commonly used or used in British system. In CGS, we have the centimeter gram second. In MKS, um, meter kilogram and second. So in physics, we commonly use the SI system. Okay, so since we have different system of units of our physical quantities from basic and derived, we have the three system of units. So we need to convert. So the topic conversion comes in. Conversion of units. Okay, let's do the conversion. What if you are given this problem? So speed. So you're given 5 meter per second and you want to convert this. So what is the equivalent in kilometer per hour? So let's do the conversion. From what you're going to do, simply copy the given. So we have this given for our solution. Let's use another color. Okay, solution. So you have copy first the given 5 meter per second, and then you have to multiply this magnitude by a quantity equal to 1. So this must be equal to 1 because any number or any magnitude multiplied to 1 gives the same magnitude, so unaffected. So, but take note, you want to convert this meter into kilometer. So you need to familiarize yourselves with the basic conversion factors. I cannot give you hint, but because you have to memorize these conversion factors. Example in meter to kilometers, mile to kilometer, vice versa. How many liters in centimeter cube. So, common conversion factors. So, sample, we have meter. So, you're going to write the meter here, meter Y, because you want to cancel the unit meter. So if you will not write, if you are going to write here sa numerator, then the meter will be multiplied. So meter times meter na meter square. So you have to write, if you want to cancel out the unit, then if it is over, then write under. So then you want kilometer, so write kilometer. So the equivalent now, in 1 kilometer, how many meters? So kilo, so 1,000. So that's 1,000. The common conversion ng kilometer. So you can now cancel the meter. So what's left? we have now kilometer. But our second, we need to convert our second to, again, hour. So in here, this should be equal to 1. So the denominator must be equal to the numerator. So the conversion should be equal, and then write second on top because it's under, so over, and then hour because we want to convert this at the time second to hour, so hour. So what's the equivalent? Wow, okay. What if you're not, yeah, you're not sure yet how many hours, but you're very sure or certain that this is equal to the equivalent in minutes. So why not use minute first instead of use directly converting the unit or the unit into hour. So let's erase. Okay, let's erase the R. Okay, and then minute on minute. Okay, let's use minute first. So how many minutes are there? Seconds in 1 minute. So this is equal to 60 seconds. Okay, then we can now cancel second in here, and what we did with the meter and second canceling out, let's also apply the same to the meter, converting meter to hour. So we have meter and then hour. So in a meter, minutes to hour, and then in 1 hour, how many minutes? 60 minutes. So we can now cancel minutes, minutes here, and we're left with what unit? We only have kilometer per hour. Okay, it's the same. So how about the magnitude or the numbers? We have 5 times 1 times 60 times 60. Okay, over 1,000. And there's no more, so 1 times 1. Okay, so what's the answer? The answer would be 18 kilometer per hour. So let's consider another example. What if you are given derive physical quantities with square or in cube? Sample density. Okay, density physical quantity. Okay, you're given 2 kilogram per meter cube. How many of this in gram per cm cube? Or why not consider as British? Okay, how about British? Feet, gram per feet cube. Okay, so again, our process, copy first the given. The given is 2 kilogram per meter cube. What happens? So write first the given 2 kilogram per meter cube. And then what you're going to do, multiply this with your with a quantity equal to 1, focusing on the units that you want to convert. So you want kilogram to be cancelled out, and then gram over. So what's the equivalent? In 1 kilogram, 1,000 grams. So kilo, still kilo. And then meter cube. So the meter cube should be placed here in the meter. And then you want, how about, let's have first a detour. Wag mo ng feet cube. So why not use centimeter first? Okay, centimeter. So what's the equivalent? In 1 meter, there are 100 centimeter. But then we have a problem. Take note of this 3 in here. So remember that the m cube, meaning the meter should be raised to the power 3. So since the whole magnitude is the number including the unit, so you need to raise this to power 3. So now we can cancel meter cube in here. But the centimeter is not yet our aim. We need to convert centimeter to feet cube, remember. So let's continue. Another quantity equal to 1. And then focusing on the centimeter, converting this unit to watt. So why not make another detour? Okay, another detour for practice. Okay, how about using inch first? So by the way, my purpose to use other conversions, other units, not directly use or the conversion to directly to feet cube, because I want you to get the concept and practice the conversion. Anyway, as long as this is multiplied to 1, this remains the same, this quantity or this magnitude. So, okay, hanap ta. So, inch. So, what's the equivalent now? Inch to cm. In 1 inch, you need to memorize the conversion factors, ha? So, in 1 inch, that's equal to 100 centimeter. Okay, but we have the problem. In centimeter in here, this is raised to power 3. So you need also to multiply this 3 times. So write 3 also in here. So we can now cancel centimeters. So let's cancel. Cancel the centimeter cube in here. The meter cube. The gram. Okay. The kilogram. So let's continue. How about multiplying again to a quantity 1? Okay, converting inch again. So under, over. Okay. Let's stop now to the feet. And then write cube in this quantity. And what's the equivalent? In 1 foot, how many inches? 12. Very common, very familiar because that's one ruler. So we can now cancel inch. Okay. Inch cube in here, inch cube. So we are left with this. So therefore this is equal to 2 times 1000 times 1 times 100 cube times 12 over 100. Okay, so the rest 1111. So there's no problem with that. Okay, for the sake of to avoid confusion. Anyway, that's still 1 equal to 1. And then what's the remaining unit? In gram per feet cube. So the answer is so this should be equal to 3, 4, 5, 6, 0, 0, 0 gram per feet cube. Or we can write this in scientific notation as 3.456 times 10 to the power 1, 2, 3, 4, 5, 6. 6 gram per feet cube. Okay, so this is our answer. What if the unit is not raised to power 3 but or not in cube but in meter square, like in area? Example, the force per unit area, the density is only in meter square. So instead of writing 3 in here, to cancel out, you need to write 2. Okay? Also write 2. So everything inside will be multiplied 2 times, not 3 times. Okay? So that's this scientific notation, this way of writing is our next topic. Okay, let me zoom this in. Okay, sample. We have the prefix nano, abbreviation N. So instead of writing how many zeros? 9 zeros. So in 1 nanometer, okay, how many meters? So instead of writing 0.1, 2, 3, 4, 5, 6, 7, 8, okay, meter. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, instead of writing this, mahaba-haba. Okay, so you can write using scientific notation and a symbol as the symbol as 1 times 10 to the negative 9 meter. Okay. So that's equivalent to 1 nanometer. So how about this one? Kilometer. Tapos na tayo sa kilometer. So how about mega? So how many meters in a megameter? A conversion using scientific notation and the symbol prefixes mega. So in 1 megameter. That is equal to um, 1 times 10 to the, what's the power? 6 meters. Okay, so that's how to, the way of writing scientific notation and using the prefixes. So I want you to familiarize, also memorize the prefix. So in short, our prefix or prefixes are used to denote very big or very small numbers. Yeah. Okay.